A lot of everything through pre-calculus is just getting you to understand graphs and their behaviors, okay? What calculus has two main things that you're dealing with. Calculus is the study of change, okay? The fact that your graphs are changing as they continue. Okay. The fact that if you go running, your speed is constantly changing. Yeah. If I go hiking, the slope of the hike that I'm on, it's constantly changing its elevation up and down, up and down. If I'm in the stock market or my money in my bank account has a graph of it going up and down, and there's always slopes that are being involved, okay? So very first thing that I want you to write, I'd actually take some sort of color and add it in there. The very first thing, and I've actually written it on that other page, is the very first star that you'll see on the top. Calculus A is only dealing with one main concept, and I want you to always remember this. Anytime that you're getting frustrated or uncertain of what you're doing in calculus, I want you to come back to this one definition.
Is it the same thing as Calc AB and Calc BC?
Calc AB, yes, Calc A and Calc B. It's just A, B, C are the three different concepts you have to understand for Calc A, Calc B, Calc C. And so AB focuses on the A and B, and then BC focuses on B and C, and then once you get into college, you have C, D, E, F, etc. Okay? But what A is focused on is a very simple, very, very direct idea, okay? And what I want you to understand is the two words that you need to memorize right away are instant and slope, okay? Now, for example, what this means is slope at a very specific point in time, okay? So imagine that I'm going on a hike right now from here up to Mount Everest, okay? And the hike is changing elevation at every different point. And so maybe in my first hour, I'm standing on a slope that is a slope of 1. And later on, I might be standing at a slope at a half. And then eventually, we might have a slope of a 2 where we got to climb and we got to start actually climbing up something, okay? And so that's what Calculus A is focused upon.
So
slope at a very specific given point of time. Now, how do we break that down? If you look on that page, what it is we're talking about slope, so the definition of a derivative. And a derivative is an instant slope, meaning that the run is as small as possible. Now, if I were to say rise is, f of x of 2 minus f of x of 1, right? Because what you have is you have the second one and you have the first one, right? And then you have that minus that is your rise, right? Mm-hmm. That minus that is your run. But you want to make this as small as possible. That makes sense? So then we end up with magnified all the way in, okay? That makes sense? So even if I did a run of 0.0001, that's still not big enough. I need infinite zeros to make it as small as possible, to make it as instant as possible. Does that make sense?
I think I get it.
Right?
So like basically the most specific
thing. Like I can go from 1.1 seconds minus 1.0 seconds, that's 0.1 seconds of time. That's still too much time to consider.
Yeah.
I want as many zeros that I can put minus, right? So I get instant slope. So over a run of almost 0. Does that make sense?
Yeah.
And so that's where we come up with this function. What you're going to notice is that in the first couple weeks of calculus, actually not maybe a couple weeks, first couple of days of calculus, your teacher is going to focus on two things. One is called limits, and one is called continuity.
I didn't get limits. That was the one thing that I actually had to.
All this is you do limit of, I can take a variable and I can make it go to 0.
Yeah.
Okay? And so what I have is rise over run, and in this situation, I want my run to be that a. And this is an action, okay? Right now, I can't put 0 in here because it would be undefined, right? If this is a big fat 0. Does that make sense? But if I was able to take, right, as many zeros as possible, if I was able to actually divide it by a value, it wouldn't be undefined. It would give me a slope. It would give me a number,
Right.
okay? And so what ends up happening is we create this function and this evaluation. And I'm going to show you with the 2 easiest ones to start off with, and then we'll expand into some practice problems of this. What you have here, and you got to be able to draw this graph out. You have an x, right? And you have an f of x somewhere along this graph, okay? We're going to get a distance of a here. They use h sometimes, okay? Sometimes they use change of x. Doesn't matter. This new value is one of these, okay? That makes sense?
Yeah.
So if I added a 3, but we want to make it as small as possible. So eventually we're going to have to put this function in there to create and evaluate it as a small value. This is our run, keep in mind, okay? So this value now, I'm just going to make it the change of x for now, just to make things easy, okay? Then we have a value up here, f of x plus the change of x. Is that fair?
Mm-hmm.
So what is my rise? My rise is this minus this, right? That minus that.
Okay.
F of b minus f of a.
Yeah.
B minus a. B minus a. Right?
Right.
Because it's run of that.
Yeah.
Okay? So this is, what you'll notice is I've given you this function. I want you to be able to draw this and give me this function. Do it yourself on that page that I've given you.
So wait.
Label all the points on here. This is just a slope graph. That's it.
Okay.
It's a slope graph with a change of x. All it is f of b minus f of a over b minus a.
So it's basically just final minus initial over initial, basically.
Right? That makes sense? So go ahead and draw this real quick, because once we're done with this, we have our slope function. We don't have a derivative function yet. The slope function will add this into it in order to make it our calculus function.
Okay.